This half-hour featurette did not originate on the Disney TV show, although it was later shown there as part of a 1962 episode titled Spy in the Sky. It made its debut in theaters in June of 1959. Disney is known for fantasy, but this film gives us a liberal dose of reality, present and future. First, it sets the stage by showing us the powerful force of weather. Then, in a very funny cartoon segment, we see how weather can affect our mood and how it has fueled many superstitions. As usual, this material is brought to life with a modern style of design and animation that most people didn't associate with Walt Disney. And there's jazzy music to match, courtesy of composer George Bruns. Narration is in the capable and creative hands of Paul Frees. We all know that the Soviet Union launched its experimental Sputnik satellite in 1957, but I've always thought of satellite's practical use as a relatively modern development. I discovered I was wrong by revisiting this 1959 documentary and learning that even then, these eyes in outer space were being used to track and forecast weather patterns. The most exciting part of this film is its projection of the future, with a dramatization of a weather control center that seems like a Hollywood science fiction movie. Except it's done so well you'd almost swear it was real.
The world of tomorrow and the instruments of science which are shaping it may seem remote and fantastic, but yesterday's fantasies are becoming today's facts. How will these great advances influence and benefit our personal lives? Here in this film is an answer. Sweeping through an eternal vacuum, through blazing heat and bitter cold, exposed to mysterious radiation, man-made satellites circle the Earth. Traveling at fantastic speeds, these eyes in outer space give us knowledge for future exploration, and also vital information that will lead to a better understanding of one of nature's great forces, the weather. With awesome violence and destruction, the weather is one of man's oldest and mightiest adversaries. But in its ever-changing moods, the weather brings us beauty. The weather gives us our daily bread. The weather makes possible all living things. And the weather certainly influences our daily lives. We have always been at the mercy of weather. When the weather is nice, we are happy. If the weather is hot and muggy, we tend to be frustrated, irritable, and even criminal. But if the fog rolls in, we are apt to be depressed. Thunderstorms cause fear and apprehension. Icy winds and snow seem to slow us down. In trying to predict these capricious changes in weather, we sometimes resort to rather questionable weather forecasting devices, such as an almanac, a crystal ball, a gouty leg, and the law of average.
April showers bring May flowers. When mule ears shake in a certain way, it means that rain will fall that day. If a spider you should slay, rain will fall within a day. It's a sign of rain and snow when the birds and bugs fly low. As the weather is on New Year's Day, for 30 days 'twill stay that way. As the weather is on January 2, for February and September the same holds true. As the weather is on January 3, so the last 3 months of spring will be. As the weather is on November 21, so the coming winter's one. Winter's one. So, as the coming winter has a New Year's Day, and if the fine weather holds its sway, the weather's bound to stay that way forever, ever, and a day.
Well, no matter how we try to predict the weather, of this we can be certain. It will always be with us. To understand it, let's look into any ocean, lake, pond, or puddle. Here in this watery world, cool and calm as can be, lives this damp little drip floating peacefully. But when the heat's on, the sun comes out. The rays, they agitate him, make him jump about. Well, he gets all shook. Look out, stand back. He's going to blow his stack. The drip evaporates, and then he's joined by his friends. They're together again. They float up high on the moist, warm air. We can't see them, but they're still there. They fly way up where the cold's intense, and back into droplets they condense, and that's what makes a cloud. But when too many droplets crowd a cloud, that crowded cloud, he cries out loud. That's the way we get the rain. Well, look who's here, the little drip again. Back in the puddle. Heat, beat, rise, skies. And that's what makes a cloud. This time those drops are blasted high. Still higher, still colder. Look at them fly. One turns to ice, another stick to it, getting bigger and bigger. Look out! I knew it! It's way too heavy! It's falling! Wow! The little drip's a hailstone now. He's back just where he was before, and the whole thing's ready to start once more. This constantly repeating cycle of weather may seem capricious and without direction, but throughout nature there is order. Weather is a constant blending of the basic elements: air, water, and sun. It all starts with the sun. This tremendous white-hot ball of gas, 750,000 miles across, supplies the power that drives our weather machine. The sun is a gigantic atomic furnace, consuming itself at the rate of billions of pounds of matter per second. Across its boiling surface drift mysterious spots. Solar flares surge in flashes of raw energy. Writhing, flaming clouds of incandescent hydrogen gas explode hundreds of thousands of miles into space. The sun is absolutely essential to life on our planet. Our Earth is surrounded by an envelope of air. Radiant energy, constantly pouring out from the sun, heats the Earth and its atmosphere unevenly from pole to equator, setting in motion broad flowing rivers of air. Wherever opposing currents of air develop, giant eddies and whirlpools are formed. These are traveling areas of low pressure in the atmosphere. The clash of these opposing air streams causes clouds to form and usually brings stormy weather. Between the areas of low pressure, there are eddies rotating in the opposite direction. Here, air pressure is high. This usually brings clear skies and fair weather. By charting their positions each day, weathermen can estimate the course they will take and the weather that will result. Keeping track of the steady parade of storms and fair weather requires the constant preparation of new maps. This is a never-ending task. Weathermen must construct these maps from a continuous flow of data that pours in from weather stations all over the world. In remote, isolated areas, in crowded cities, in high-flying aircraft, and in ships at sea, modern weathermen depend on a variety of specialized instruments to gather information. They measure temperature, moisture, air pressure, and wind speed. Balloons carry instruments aloft, automatically radioing back information. New radar techniques locate and track storms. And modern electronic computers now play an important part in weather forecasting by their ability to store and rapidly process vast amounts of data. But today, we are just beginning to understand something of the forces behind the weather. Scientists realize they must search in many directions and ask countless questions. For instance, can future weather be predicted by looking at the past? Does the slow advance and retreat of glaciers over periods of centuries indicate cycles in the Earth's climate? Past records of bird and animal migration, or the migrations of man, may furnish clues. And even ancient tree rings give an indication of wet and dry periods. The vast unexplored polar regions of the Earth pose another kind of question. What effect do these frigid areas, covering millions of square miles, have on the weather of the entire world? Auroras, the ghostly lights that flicker in polar skies, tell something of what happens when energy from the sun plunges into the sea of air that surrounds the Earth. Adventurous scientists are probing the atmosphere itself, climbing to incredible altitudes in their search for knowledge. New scientific tools are being used, rockets launched from balloons. And rockets launched from the ground carry instruments higher and higher. Unfortunately, these flights last but a short time, and only a small amount of information can be obtained. But now we have more advanced scientific devices for gathering data continuously over long periods of time, not only from the atmosphere, but from space beyond. Artificial satellites. Satellites reach into the unknown with instruments that duplicate man's own senses. The eye of the satellite is a photocell or a radiation counter. Its ear, a tiny microphone. Its memory, a tape recorder. And its voice is a radio transmitter. Here, these instruments are placed in an actual weather satellite, designed to record the cloud formations covering the Earth. In this cross-section view, we see how all the instruments have been reduced to an amazingly compact unit weighing but a few pounds. Here is one of the electronic eyes of the satellite. This eye converts the light reflected from land, ocean, and cloud into electrical impulses. These impulses from the eyes are changed into electronic signals that are recorded by this tiny tape machine. Recording continuously for periods of nearly an hour, this incredibly small instrument remembers everything the weather satellite sees. Triggered by a radio signal from Earth, the recorder plays back the stored information in only 1 minute. These precious reports on the Earth's cloud patterns are received by specially designed stations on the ground. The radio signals from the satellite are now converted back to a moving pattern of light on the oscilloscope, and finally translated into a picture of the cloud formations the satellite has seen during one trip around the Earth. Today's weather satellites are small and are designed to do a limited job. However, they are the first step forward to larger and more versatile space explorers of tomorrow. These future satellites will be the key to precise forecasting and control of weather. Let us project our present knowledge with a little imagination and speculate on how satellites might be used in future operations from a worldwide weather center. This is the master control room. Electronic maps and view screens display up-to-the-minute pictures of the weather around the Earth. Every hour, reports are automatically received from all points at sea, on land, and in the air. 22,000 miles out in space, 3 robot satellites train their sensitive television eyes on all parts of the Earth. These pictures are monitored on viewing screens in the Weather Center. Here in the computing room, electronic machines digest the constant flood of information received from all stations. This is then translated into an ever-changing diagram of the Earth's weather. Forecasts for every sector of the globe are made months in advance. Prediction charts have indicated that a powerful hurricane will begin forming today in the Atlantic Ocean. The electronic weather map shows an intense storm system building up about 1,000 miles due east of Miami, Florida. The controller calls for a close-up satellite view of the troubled area.
Coordinates. Coco 526, Yankee 2.5.
Okay, controller. Coco 526, Yankee 2.5.
The characteristic swirling clouds of the hurricane are beginning to form. At sea, the waves anticipate the violence to come. The controller calls for a last-minute prediction of the hurricane's path. If control measures are not begun at once, the hurricane will smash across densely populated areas within 48 hours.
11 a.m. EST. A hurricane is forming 960 miles east of Miami, Florida. If control measures are ineffective, it will pass inland at Cape Hatteras in 48 hours. Control operations will begin within 2 hours, but safety precautions should be completed from Cape Fear, north no later than 6 p.m. tomorrow.
At Weather Central, the control strategy is mapped out. A ridge of high pressure slants across the eastern United States between 2 low-pressure storm systems. If these 2 storm centers are intensified, the high will build up along the coast, forming a barrier that will turn the hurricane out to sea.
Stand by. Now pulling in satellite number 1 for visual check of low-pressure systems L20 and L21.
The operator brings the satellite into focus on the 2 storms. One centered over Kansas, the other over Labrador.
Changing the northeastern low, L21.
With the touch of a button, the battle begins. On the ground, chemical cloud seeders begin to work the two storm areas. Robot planes seed the clouds from above. The storm centers over Kansas and over Labrador intensify as seeding continues.
Now changing over to Hurricane Center H8.
The fury of the hurricane mounts as 100-mile-an-hour winds lash the sea to a foaming frenzy.
All stations, Sector C. Activate Phase 2, Control Plan Delta. Set vapor rockets for 42,000 feet.
As an emergency measure, the controller calls for a salvo of vapor rockets to be fired ahead of the path the hurricane is predicted to take. These artificial clouds will block the sun from evaporating more water to feed the hurricane. The reports coming into the control center indicate that the diversionary cloud seeding over Kansas is now creating a flood danger. Specially equipped robot aircraft are dispatched immediately to release a high concentration of cloud seeding material into the fringes of the storm. Heavier seeding from the ground also helps to subdue the rain by spreading it over a wider area. The controller calls for another view of the hurricane, which has now moved closer to the coast.
Signal out on number 1 satellite. 10-minute interruption for correction. Have you anything else in the area?
Satellite station S1 is approaching area. We'll make contact. S1, this is Weather Central. Request video signal at grid coordinates COCO.
An emergency situation has developed. In an orbiting space station 1,000 miles above the hurricane, a crewman sends a temporary picture back to Weather Central.
Okay, S1, your video is R5S5. Thank you.
The hurricane has stopped moving toward the coast, but is still intensifying. It must be made to move northward and out to sea. This is a crisis.
Aberdeen Station. Activate multiple seeding rockets on course 117.
The controller decides to fire cloud seeding rockets just ahead of the hurricane, hoping to start it moving. Slowly, the hurricane begins to shift. All available forces have been brought into play. Now we can only watch and wait. After hours of tension, the turning point is reached. Latest reports indicate the control strategy is successful. At last, the high-pressure ridge has settled along the coast, forming an invisible wall of safety. The storm is over. The danger has passed. The hurricane has been defeated, turned away from the land, and left to spend itself harmlessly far out at sea. In the world of tomorrow, weather control will enrich and safeguard our daily lives. In the foreseeable future, we will conquer more than violent storms. We will turn the destructive elements of today into new sources of power, shaping the land on which we live. All mankind will benefit. Arid wastelands will be made green and fertile, and vast frozen areas will become productive. To this end, man-made satellites will probe the secrets of the skies. They will be our eyes in outer space.
When I was in school, my friends and I dreaded most of the educational films we were forced to watch. But if the projector started, this is long before video, I'm afraid, and we saw the words, "Walt Disney Presents," we breathed a sigh of relief. That's because we knew we'd be entertained, and we'd learn things in creative ways our teachers could never compete with. After all, the people who created these so-called educational films were the same people who made Snow White and the Seven Dwarfs, Bambi, and all the other great Disney features. I don't know who but Walt Disney would have even attempted to tell the story of atomic energy within the framework of an hour-long entertainment show. But he was deeply committed to science and education, and even put his team to work on this book, which accompanied the TV show and became an enduring success in its own right. Our Friend the Atom premiered on January 23, 1957. Typically, the program takes us back to ancient Greece and then marches through the centuries to show us milestones in scientific progress. And just as typically, the Disney folks managed to sugarcoat the learning process by comparing atomic energy to a genie in a magic lamp. But this isn't patronizing. It makes every point crystal clear, even to a scientific dunderhead like me. I can't think of a more perfect way to illustrate an atomic chain reaction than using mousetraps, as they do in this film. Dr. Heinz Haber is our host and guide, and while he's not the most charismatic man in the world, he does his job well. Most importantly, he stresses the point that atomic energy can be a terrible force unless it is tamed. I think it's safe to say that back in the 1950s, neither Dr. Haber nor Walt Disney envisioned the potential problems that would come to be associated with nuclear power. They saw it as a clean source of energy with no downside whatsoever. So, as you watch this film, please bear that in mind. After all, Walt was an optimist. Who else would have called a program like this Our Friend the Atom?
Walt Disney's Disneyland.
When you wish upon a star, makes no difference who you are.
Each week as you enter this timeless land, one of these many worlds will open to you. Frontierland. Tall tales and true from the legendary past. Tomorrowland. Promise of things to come. Adventureland. The wonder world of nature's own realm. Fantasyland. The happiest kingdom of them all. Presenting this week,
many years ago, a prophetic writer and engineer told of the genius of one man who discovered the very power of the universe and harnessed it to propel his ship 20,000 leagues under the sea. But the hero of that story was afraid to let this power fall into the hands of an immature mankind. And so he chose rather to destroy his own work. Yet there is hope. In God's good time, nature's own energies will come to humankind for a better and a richer life.
Fiction often has a way of becoming fact. Not long ago, we brought you the immortal tale, 20,000 Leagues Under the Sea, featuring the famous submarine Nautilus. According to the story, this craft was powered by a magic force. Today, that tale has come true. This is a model of the real Nautilus, the world's first atom-powered ship. It's the first example of the useful power of the atom that will drive the machines of our atomic age. The atom is our future. It is a subject everyone wants to understand. So we felt it was the most important topic for a Tomorrowland program. In fact, we considered it so important that we embarked on several atomic projects. For one, we made plans to build an exhibit at Disneyland that will show you atomic energy in action. Now, our atomic projects here at the studio are twofold. We prepared this program and also a book so that we could tell you this important story in full detail. Both grew together. We gave them the same title, and many of the illustrations appear in both. As you can see, we found ourselves deep in the field of nuclear physics. Of course, we don't pretend to be scientists. We're storytellers. So we combine the tools of our trade with the knowledge of experts. We added a nationally known scientist to our staff to head our new science department. His first assignment was to write the book on the atom and to help us in developing this program. And here to tell you the story of our friend the atom is the author of our book, Dr. Heinz Haber.
As we developed our story of the atom, we made an amazing discovery. We had a science story, but suddenly we realized that it was almost like a fairy tale. By a strange coincidence, our story turned out to be like the old fable from the Arabian Nights, the fisherman and the genie. This tale tells of an age-old wish of man, a wish to be the master of a mighty genie that does his bidding. There was once an old fisherman who lived in great poverty. One day, after casting his net many times, he happened to pull ashore a brazen vessel. Its mouth was closed with a lead stopper. Marveling at his strange catch, the fisherman said,
"I'll wager that whatever is sealed so well must contain something of great value."
Know that presently thou wilt have to die.
Heaven forbid! Or at least tell me why.
As I lay imprisoned in that tiny jar for many centuries, my anger grew and grew until I swore in my heart that my liberator should perish.
What a cruel trick fate hath dealt me. Trick? Oh, genie, since thou art determined upon my death, grant me this one last question.
Well?
How can one as mighty and powerful as thou dwell in so tiny a vessel?
What? Thou dost not believe me?
Not till I have seen it done can I believe it.
Watch then.
Now you shall return to the sea.
Nay, I did not mean what I said. No, release me, and I give my solemn vow to grant thee 3 wishes.
Strangely enough, our story is like that fable, come true through science. We are like the fishermen. For centuries, we have been casting our net into the sea of the great unknown in search of knowledge. And finally, we found a vessel. And like the one in the fable, it contains a genie. A genie hidden in the atoms of this metal, uranium. Let me show you. This is a Geiger counter. It tells us that the genie is here, imprisoned in these atoms. So this is our story. How the vessel was discovered, how the genie was liberated, how he first threatened to kill, and how he was finally harnessed to grant us 3 wishes. Our story begins in ancient Greece in 400 BC. At that time, man firmly believed that all things were composed of 4 basic elements: earth, air, water, and fire. But Democritus, a philosopher of that era, thought that these elements could be divided into smaller particles. In fact, he even gave them their name, atomos, which means indivisible.
I crumbled this earth to soil, and in turn crumbled this soil to dust. Now, if I could reduce this dust into its smallest particles, these would be atoms. This beach appears to be a solid carpet, but on closer inspection, we see that it is made of millions of grains of sand. If we think of grains of sand as atoms and pack them together, they can be molded into any desired form. So it is in this way nature uses these tiny particles, these atoms, to build all things: the earth, water, air, and fire.
If air and fire consist of small particles, how can they rise? They would fall to the earth like a shower of pebbles.
The man who disagreed with Democritus was Aristotle, a famous Greek philosopher. His philosophy shaped the thinking of man for the next 2,000 years. And so the idea of the atom was lost. In the 17th century, man went beyond mere thinking. He began to act. His philosophy became seeing is believing. He invented the telescope, and this magic instrument greatly extended his range of sight. He saw mountains and craters on the face of the moon. He found that the planet Venus also showed phases just like our moon, and that Jupiter has moons of its own. He saw for the first time the reddish disk of Mars and the beautiful rings of Saturn. With a telescope, man discovered the universe in all its unbelievable richness. At about the same time, a second powerful instrument was invented, the microscope. It opened up an entirely new and tiny world for man to explore. It was a world full of strange patterns and designs. man found them in ordinary things such as wood, in the feathers of birds, in the bodies of insects, and in the scales of fish. The microscope revealed infinite details in everything. There was hidden beauty in miniature seashells, so tiny that millions of them form only a wisp of powder. Even a single drop of pond water revealed forms of life never before seen. Tiny, one-celled animals and plants. The microscope gave man his first look into nature's miniature universe, a world teeming with fantastic forms of life. With the microscope, man also discovered the beautiful and regular forms of crystals. He marveled at the delicate shapes of snowflakes. In thousands, no two are alike. In the regular shapes of crystals lay hidden the secret of the atom's existence. Of course, the microscope doesn't show atoms. They are much too small for that. But it made man aware that everything he saw and discovered must be composed of something still smaller. One of the first men to explore nature's tiny realm was John Dalton, an English chemist. This was early in the 19th century. It was he who revived the idea of the atom.
I believe Democritus was right. All things are made of atoms. Take copper, for instance. My drawings show how the atoms group together. They are like little, hard, indestructible balls, with some unknown force acting between them. When the atoms pack together, layer upon layer, millions upon millions, then they build a tiny crystal. And when the crystals combine, they form the copper metal we are so familiar with.
And there are also atoms for silver and gold. There are different kinds of atoms everywhere. Atoms for sulfur in a match. Atoms for carbon in every ordinary pencil. Atoms for mercury in a thermometer. A different kind of atom for each element. But most of nature's creations are mixtures. This glass is a mixture of different kinds of atoms. The wood here, another. This book is composed of more mixtures than I could name. The secret of how nature creates her mixtures was first understood in 1811 through the work of Amadeo Avogadro of Italy.
When atoms of different elements combine, they form into small, compact masses, which I call molecules. I have found that there is a different proportion of atoms for each kind of molecule. For example, when one atom of oxygen combines with two atoms of hydrogen, they form the most common molecule in nature. This, of course, is H2O, water.
It takes billions and billions of these water molecules to make a single drop of water. They are so tiny that they cannot be seen, even through the most powerful microscope. However, the microscope does reveal an important fact about atoms and molecules. It shows that they are in constant motion. These are dust particles in a drop of water, and you can see that they are being kicked around by the ever-busy water molecules. It was over 100 years ago that an early microscope first revealed that atoms and molecules are constantly on the move. Now, in a flame, for example, the motion of the atoms and molecules is extremely violent, and this is why a flame is hot. Our skin is equipped with tiny organs that can feel this violent movement as heat or even pain. Now, in this glass, the molecules are moving much more slowly, and so it feels normal to the touch. Even in an ice cube, the molecules are moving, but very slowly. And this is why the ice feels cold. Let's look at heat with an atomic eye, so to speak. Atoms, of course, don't burn up. They merely rearrange themselves, forming molecules of soot and ashes. So that you can see what is going on, we will exaggerate the size of the atoms over 1 billion times. The molecules in the flame dash around with great speed and bounce against the molecules of the glass. They transfer their violent motion to the glass and finally to the ice. It's like a pool game with the balls bouncing against each other. If more heat is applied, the ice molecules will move faster and faster and finally break loose from each other. The ice melts. As the movement becomes more violent, the water begins to boil. The molecules are kicked away from the surface as steam. In hot steam, they're dashing around with great force, enough force to bounce the lid of the jar. There is power in steam, power that can do more than just lift the lid. When this force was put to use, it ushered in the mechanical age. Steam that turned our generators to produce electric power. And the gaslight era then became the age of electricity. True, steam was a mighty servant, but it was a hungry servant. It had to be fed constantly, and satisfying its hunger cut deep into our precious resources of coal and oil. Man had not yet found the genie of our story. In fact, he hadn't even found the vessel in which the genie was imprisoned. The year was 1896. Again, in search of knowledge, the net was cast into the sea of the unknown, and like in our fable, a catch was made, an accidental catch. The discovery was made by Henri Becquerel, a French scientist.
Today I discovered something very strange. I happened to leave a piece of uranium on a wrapped photographic plate in a dark drawer. When I developed the plate, I found that it was fogged. Apparently, the uranium had exposed it, even in the darkness and through the wrapping. This uranium, it seems to possess some mysterious activity and give off some type of radiation all by itself. C'est extraordinaire.
Becquerel had discovered radioactivity. Pierre and Marie Curie, two other French scientists, were greatly intrigued by this strange phenomenon. While seeking the source of the radiations from uranium, they discovered a new element which gave off even stronger rays.
our new element. How radiant it is. It even glows in the dark. We should call it radium.
Radium turned out to be a mysterious source of energy. This remarkable element would go on radiating like an endlessly flowing spring. This was against all laws of science known at that time. How could this tiny mass contain so much energy? This mystery shook the very foundations of science. It was finally understood in 1905 when Albert Einstein discovered an important new law. His theory showed that every mass contains a tremendous amount of energy.
E stands for energy, M for mass, and c squared is the speed of light multiplied by itself. Now, c squared is a very great number, and so, if multiplied by even a small mass, the result will be a very great amount of energy.
This is a cold scientific explanation, but its deep meaning can be easily understood through our fable. Einstein, like the fisherman, found that a mighty force was contained in a small vessel. Radium constantly releases tiny bits of its energy through radiation, a little bit every second. And there is so much energy that this activity can go on for thousands of years. These rays were actually tiny fragments of atoms breaking apart. No longer could the atom be considered the smallest particle in nature. Evidently, the atom was not an indestructible little ball after all. But then, what was it? The first clue to this question came from Lord Ernest Rutherford of England. The year was 1911.
Today, I used the fast-flying fragments of radium as tools to probe into the atom. I placed a small sample of radium inside a solid lead block. The lead absorbed all the rays except those that were allowed to escape through a small opening in the block. One might say it was a sort of atomic gun. To make the ray bullets visible, I used a fluorescent screen. For a target, I chose a very thin leaf of gold. But to my surprise, the bullets from my atomic gun passed right through the gold leaf as though it wasn't there. It was like shooting at a ghost. This was truly amazing because the gold leaf was a solid wall, 2,000 atoms thick. So the atom can't be as solid as we always thought. Then, unexpectedly, one out of thousands of bullets ricocheted, striking something solid. I can only conclude, then, the atom is mostly empty space, like a cloud or shell. But occasionally I hit something solid. It must be very small, a tiny particle in the center. I shall call it the nucleus of the atom.
With Rutherford's discovery of the nucleus, scientists began to understand how nature builds her atoms. The shell of the atom appears solid, just as a fast-whirling fan seems solid. Actually, the shell is composed of a whirling swarm of tiny electrical particles called electrons. They circle around the nucleus like planets around the sun. So the atom is like a tiny solar system. But scientists are ever curious. Like the fishermen who examined the vessel he had hauled ashore, they began to probe the atomic nucleus for its secrets. They found that it was composed of small particles electrically charged. They called them protons, which means primary particles. Later, to the great surprise of science, other strange particles were discovered in the nucleus. They had no electrical charge. They were neutral, and so they were called neutrons. At last, the mystery of the atom structure was solved. How amazing nature is. Think of it. There are countless solar systems of atomic suns and planets in everything. There's a whole universe in the tip of a pencil. Even in this tiny pencil dot, there are billions of times more atoms than there are people on our Earth. There are many kinds of atoms. It's interesting to see how they differ in the various elements. It's a fascinating study in numbers. Let's start with number 1. The simplest atom in nature. 1 proton and 1 electron give us the element hydrogen, a very light gas. Nature always keeps an electrical balance in her atoms. So, if the nucleus has 2 protons, it will also have 2 circling electrons. This makes an atom of helium. There are also neutrons in the nucleus that add to its weight. And so, by simple addition, nature builds the atoms of all her elements. 6 protons and 6 electrons and some neutrons for carbon. (16 and 16) for sulfur. 26 iron. 47 silver. 79 gold. 92 uranium, the famous radioactive element. Here, nature has crowded so many protons and neutrons into the nucleus that it becomes unstable. Finally, it throws out a small fragment, and in this way, radioactive rays are born. These rays cannot be seen, heard, or felt. The Geiger counter is used to detect their presence. It gives off audible clicks when the rays pass through it. And there is another instrument which even makes the rays visible to the naked eye. This special device is called a cloud chamber. It contains a tiny bit of radium which gives off a constant shower of atomic fragments. Of course, the fragments themselves are much too small to be seen, but you can now see their trails. Each new vapor trail shows that another atom has thrown off a fragment. Each atom does this only once in its entire life. But there are so many atoms that this activity is going on almost endlessly. We might say that a radioactive atom is like a set mousetrap. Both contain energy. The traps on this table represent the atoms in a piece of radium. Every so often, one breaks down all by itself, releasing a bit of energy. But radium is useless as a power source. There aren't enough atoms releasing their energy at the same time. But nature knows all the secrets of the atom. Since the beginning of time, she has used atomic energy to power the whole universe and to light the fires in the sky. The best example is our own sun. These are actual time-lapse pictures of the sun's rim. That vast display of energy comes from an atomic fire raging deep in the core of the sun. If this was an ordinary fire, the sun would burn to a dead heap of ashes within a few thousand years. But so much energy is produced by these atoms that the sun will go on shining for billions of years to come. For a long time, nature alone knew how to open the vessel that contained this mighty force. To man, however, the vessel remained closed. Finally, he discovered the secret of how to open the vessel himself. The fisherman used his knife, and man, too, found a tool that broke the seal. The year was 1938. The place, Berlin, Germany. The leading character, that strange metal, called uranium. Again, it turned out to be the star of a sensational scientific discovery. Otto Hahn and Fritz Strassmann were probing the secrets of the uranium atom. Like Rutherford, they used atomic bullets. They used neutrons, the neutral particles that were discovered hidden in the nucleus of the atom. The neutron is an ideal bullet. Since it is neutral, it isn't deflected by the electrical charge of the atoms and flies through them in a straight course. Finally, it struck a nucleus. The uranium nucleus split in two. Atomic fission had been accomplished. But this wasn't all that happened. Two neutrons were released from the split nucleus. One bullet was used to split the atom, and two new ones were created in the process. Now we have two neutrons to split two atoms. This implied a fabulous prospect, a nuclear chain reaction in uranium. Let's go back to our mousetrap atoms. We can create a chain reaction with them. We'll use our two ping pong balls for neutrons. They will be released when the atom splits. Now all these mousetraps are the atoms that will be in the game. They are set, loaded, and ready to go. To start the chain reaction, all we need is one neutron. It has to trigger just one trap. The ping pong balls that are released will set off two other traps. And then we'll have four balls flying to trigger more traps. I think you can see what is going to happen. Watch. An atomic chain reaction works in exactly the same way. One neutron is enough to start it. The atomic genie was freed, and his devastating force posed a fearful threat. The world was deeply shocked by the first atomic explosion. We all wondered if atomic energy had better remained a secret forever. We are like the fisherman. When he first beheld the frightful form of the genie, he too wished that he had never found the vessel.
Know that presently thou wilt have to die.
Heaven forbid!
But our fable had a happy ending. The fisherman had his means of making a friend of his enemy. And fortunately, science has its way of doing the same thing. An atomic blast is more than a threat. It is also a regretful waste of heat and radiation. To make this energy useful, the explosion must be slowed down. Let me show you what I mean. Our mousetrap explosion can be slowed down with the aid of a slow-motion camera. As you can see, the chain reaction is now spread over a longer period of time. The energy is released slowly, and the heat and radiation stay within useful limits. Atomic scientists produce slow nuclear chain reactions within the famous atomic reactor. It's really just a furnace with thick concrete walls to encase the atomic fire. Blocks of uranium serve as atomic fuel. To slow down the chain reaction, control rods that absorb neutrons are inserted in the blocks. These rods act like a damper in the furnace and catch some of the flying neutrons and take them out of play. This allows fewer atoms to split and keeps the reactor burning almost endlessly at an even temperature. With the chain reaction thus under control, the mighty atom can be put to use. The heat is picked up by a liquid that is piped through the hot core of the reactor. The heated liquid is then run through a boiler where it produces an almost endless stream of hot steam. Steam for power. But there's more than heat. The atomic reactor has the magic power to make many ordinary materials radioactive. If, for example, a piece of iron is exposed to the shower of neutrons inside a reactor, the iron atoms pick up extra neutrons and become radioactive. In this way, the reactor creates for us artificial radioactivity in many elements. Like natural radium, they are valuable tools in science and medicine. The atomic reactor, then, gives us a chance to make the atomic genie our friend. He will come forth to our beckoning, and just as in the fable, he will grant us 3 wishes. The decision is ours. What should we wish for? What do we need most? Our coal and oil will not last forever. Yet we need ever more power. So, For the growth of our civilization, our first wish shall be for power.
Here with my right hand, I give you the magic fire of the atom. It is yours.
The atomic fire is an almost endless source of heat. We can use it in power stations for producing electricity. Electric power of our modern civilization. And then, the atom will run our ships. And of course, the atomic submarine already exists. The atomic fire can heat air as well as water. Then the atom becomes the driving force of a jet engine. It can drive an airplane. An airplane that circles the world many times without ever landing for fuel. And eventually the atom will help us to cast off the shackles of gravity and fly through the vast reaches of outer space. Here we are, burning up our coal and oil only to produce power. But now we have a new source of power. Clean, silent, plentiful. Coal and oil can now be saved for better things. We can use them for making plastics, dyes, textiles, and drugs. Mankind has ever suffered from hunger and disease. So our second wish shall be for food and health.
With this hand, I give you a source of beneficial rays. They are magic tools for research that will help you to create food and to cure diseases.
Magic tools, indeed they are, these radioactive rays. For example, an ordinary needle can be made radioactive. And then, if it is hidden in the proverbial haystack, it can easily be found by the rays it gives off. Like this needle, all radioactive materials can be traced by their telltale rays. With radioactive chemicals, we can now literally watch how plants grow, and we can trace plant nourishments from soil to fruit. In this way, science will help to produce bigger and richer crops. The growth of animals can be studied in the same way, and the best food can be found for better and healthier livestock. So the atom creates more food for our ever-growing population. And these same rays are the tools of atomic medicine. Radioactive sodium, for example, is used for timing the flow of blood through the living human body. It is injected into the arm, and then a Geiger counter will record how long it takes to reach the heart. This is a great help in recognizing heart conditions. In diseases of the thyroid gland, radioactive iodine performs an amazing job. If mixed in an atomic cocktail, it will gather in the thyroid because iodine is attracted to this gland. A special Geiger counter then automatically traces an accurate picture of the thyroid, showing its size and location and how fast it collects the iodine. Radioactive elements can also heal. Phosphorus, for example, lodges in the bones, where its mild radiation can cure certain blood diseases. The patient carries his treatment with him, even while he works and sleeps. And then, radioactive cobalt is used in the famous cobalt bomb. But this bomb is a friendly one that is used in hospitals for fighting that dread disease, cancer. And there is left to us the third and last wish. It is an important choice. Many legends tell of how wishers made an unwise choice, and how their last wish destroyed the benefits of the first two. The atomic genie weighs in his hands the powers of both creation and destruction. As yet, the world has reason to fear those destructive powers. So our last wish should simply be for the atomic genie to remain forever our friend. We have inherited a wealth of knowledge from the great thinkers of the past. That this heritage would ever be applied towards destruction was farthest from their minds and hearts. It lies in our own hands to make wise use of the atomic treasures. Then the magic touch of the genie will spread throughout the world, and he will grant the gifts of science to all mankind. The great scientists before us gave us knowledge of the atom, and our last wish will come true if we use the power of this knowledge in their spirit. Then the atom will become truly our friend.
Now, in motion picture theaters everywhere, you'll be able to see for the first time Walt Disney's new Technicolor feature, Westward Ho the Wagons. It's a new and different outdoor drama telling the exciting story of the covered wagon families fighting their way west, told against a background of spectacular scenic beauty in CinemaScope and Technicolor. Westward Ho the Wagons. Now, you and your family can see this exciting motion picture entertainment in a theater or drive-in nearby. Look in your newspaper for theater names and showtimes. This has been an ABC Television Network film presentation.
Here's an exceptional piece of film made by Walt Disney in October of 1966 to tell the people, and especially the legislators of Florida, what he planned to do with the project then known as Disney World. Although it's been excerpted over the years, the entire film has never been shown to the general public until now. For me, the most exciting part of Walt's plan is Epcot, not the futuristic theme park as it now exists in Orlando, but a model city. This had my head spinning when I was a kid, and frankly, I still find the idea captivating. The Disney Company has created a town alongside Walt Disney World called Celebration, Florida, but even that planned community hasn't incorporated some of the visionary ideas Walt outlined so many years ago in this film. The text for this cinematic prospectus was written by Marty Sklar, whom you'll meet elsewhere on the disc. But the pitchman was the one and only Walt, who is in rare form, energetic, upbeat, confident, and persuasive. It's hard to believe that he passed away just 2 months later.
Welcome to Disneyland, USA. This was all a Disney dream a dozen years ago, a far-out project that was totally unproved. Today, 60 million people have come here from every state in America and from almost every nation around the world. In Town Square on Main Street, many have paused to read the dedication plaque that symbolizes the warm and friendly spirit of Walt Disney's Magic Kingdom. To all who come to this happy place, welcome. Disneyland is your land. Here, age relives fond memories of the past. And here youth may savor the challenge and promise of the future. Disneyland is dedicated to the ideals, the dreams, and the hard facts that have created America, with the hope that it will be a source of joy and inspiration to all the world. Disneyland grew out of Walt Disney's own feeling that an amusement park should offer more to the entire family. Here was no mere amusement park. Here was a whole new concept in entertainment, where parents and children could have fun together. The touchstone of Disneyland's success has been its concern for people, a wholehearted dedication to the happiness of the people who visit here. Today, Disneyland has established standards of performance unsurpassed in all the world. Yet in the planning and building, there were no standards to follow. Whatever worked became the code. Whatever failed to meet the public need was changed, replaced by a better idea. People and vehicles are constantly in motion at Disneyland. Here, people travel aboard almost every method of transportation man has ever designed. Provocative new ideas, like the first monorail system in the Western Hemisphere, have demonstrated their potential in this practical proving ground. Disneyland vehicles have carried 340 million passengers in comfort and speed, and have traveled more than 19 million miles in unequaled safety. To plan Disneyland, Walt Disney long ago established a design organization called WED Enterprises. Today, the staff at WED includes designers, architects, and engineers skilled in the Disney way, and also fine craftsmen and technicians skilled in the arts of the space age. What WED does is called Imagineering, the blending of creative imagination with technical know-how. The talents of WED have gone to work outside Disneyland, too. At the New York World's Fair, 4 of the most popular attractions were Disney shows and corporate exhibits that skillfully welcomed and entertained more than 150,000 people every day. Tribute to the achievements of the Disney design staff has been paid by many highly respected planners and builders. Among them, James W. Rouse, developer of the new town of Columbia. In his keynote speech before the 1963 Urban Design Conference at Harvard University, Mr. Rouse said in part, quote, "I hold a view that may be somewhat shocking to an audience as sophisticated as this, that the greatest piece of urban design in the United States today is Disneyland. If you think about Disneyland and think of its performance in relation to its purpose, its meaning to people, more than that, its meaning to the process of development, you will find it the outstanding piece of urban design in the United States. It took an area of activity, the amusement park, and lifted it to a standard so high in its performance, in its respect for people, in its functioning for people, that it really has become a brand new thing. It fulfills all the functions it set out to accomplish, unself-consciously, usefully, and profitably to its owners and developers. I find more to learn in the standards that have been set and in the goals that have been achieved in the development of Disneyland than in any other single piece of physical development in the country." End quote. Yesterday, Disneyland and the New York World's Fair. Tomorrow, a project so vast, it has already been called a whole new Disney world. And now, here is Walt Disney.
Welcome to a little bit of Florida here in California. This is where the early planning is taking place for our so-called Disney World project. Now, the purpose of this film is to bring you up to date about some of the plans for Disney World. But before I go into any of the details, I want to say just a word about the site of our Florida project. As you can see on this map, we have a perfect location in Florida, almost in the very center of the state. In fact, we selected this site because it's so easy for tourists and Florida residents to get here by automobile. Now, in larger scale on this map, our Florida land is located partly in Orange County and Osceola County, between the cities of Orlando and Kissimmee. And the important thing is that the Disney World is located just a few miles from the crossing point of Interstate 4 and Sunshine State Parkway, Florida's major highways carrying motors east and west and north and south to the center of the state. The sketches and plans you will see today are simply a starting point, our first overall thinking about Disney World. Everything in this room may change time and time again as we move ahead. But the basic philosophy of what we're planning for Disney World is going to remain very much as it is right now. We know what our goals are. We know what we hope to accomplish. And believe me, it's the most exciting and challenging assignment we've ever tackled at Walt Disney Productions. Today, I want to share with you some of our ideas for Disney World. Now, the prologue to this film told you some of the philosophy that made Disneyland in California what it is today. Of course, there will be another amusement theme park in Florida, similar to the one in California. We're now developing a master plan that encompasses the theme park and all the facilities around it that will serve the tourists. Hotels, motels, and a variety of recreation activities. In fact, just this little area alone is 5 times the size of Disneyland in California. But as you can see on this master plan, the theme park and all the other tourist facilities fill just one small area of our enormous Florida project. According to this scale, I am 6 miles tall. Now that's 12 miles from here up to here, and the whole area encompasses 27,400 acres. That is 43 square miles, twice the size of the island of Manhattan. Now, the area we propose to develop is between the Reedy Creek Swamp and the Bonner Creek Swamp. So one thing we don't need is a fence to protect us from trespassers. Here in Florida, we have something special we never enjoyed at Disneyland, the blessing of size. There's enough land here to hold all the ideas and plans we could possibly imagine. Right now, our plans include an airport of the future down here in Osceola County, an entrance complex where all visitors will enter Disney World, an industrial park area covering about 1,000 acres, and of course, the theme park area way up here. And all these varied activities around the Disney World will be tied together by a high-speed, rapid transit system running almost the full length of the property. But the most exciting, the most important part of our Florida project, in fact, the heart of everything we'll be doing in Disney World, will be our experimental prototype city of tomorrow. We call it Epcot, spelled E-P-C-O-T, Experimental Prototype Community of Tomorrow. Here it is in larger scale. Epcot will take its cue from the new ideas and new technologies that are now emerging from the creative centers of American industry. It will be a community of tomorrow that will never be completed, but will always be introducing and testing and demonstrating new materials and new systems. And Epcot will always be a showcase to the world for the ingenuity and imagination of American free enterprise. I don't believe there's a challenge anywhere in the world that's more important to people everywhere than finding solutions to the problems of our cities. But where do we begin? How do we start answering this great challenge? Well, we're convinced we must start with the public need. And the need is not just for curing the old ills of old cities. We think the need is for starting from scratch on virgin land
and building a special kind of new community. So that's what Epcot is, an experimental prototype community that will always be in a state of becoming. It will never cease to be a living blueprint of the future, where people actually live a life they can't find anywhere else in the world. Everything in Epcot will be dedicated to the happiness of the people who will live, work, and play here, and those who come here from all around the world to visit our living showcase. We don't presume to know all the answers. In fact, we're counting on the cooperation of American industry to provide their very best thinking during the planning and the creation of our experimental prototype community of tomorrow. And most important of all, when Epcot has become a reality and we find the need for technologies that don't even exist today, it's our hope that Epcot will stimulate American industry to develop new solutions that will meet the needs of people expressed right here in this experimental community. Well, that's our basic philosophy for Epcot. By now, I'm sure you're wondering how people will actually live and work and move around in our community of tomorrow. So in the next few minutes, we'll go into detail about some of our preliminary sketches and layouts. Remember though, as I said earlier, this is just the beginning. And with that thought in mind, let's have a look.
No city of today will serve as the guide for the city of tomorrow. Epcot will be a planned environment, demonstrating to the world what American communities can accomplish through proper control of planning and design. Epcot begins with an idea new among cities built since the birth of the automobile. We call it the radio plan. Picture a wheel. Like the spokes of the wheel, the city fans out along a series of radials from a bustling hub at the center of Epcot. A network of transportation systems radiate from this central hub, carrying people to and from the heart of the city. These transportation systems circulate to and through 4 primary spheres of activity surrounding the central core. First, the area of business and commerce. Next, the high-density apartment housing. Then the broad green belt and recreation lands. And finally, the low-density neighborhood residential streets. Epcot's dynamic urban center will offer the excitement and variety of activities found only in metropolitan cities: cultural, social, business, and entertainment. Among its major features will be a cosmopolitan hotel and convention center, towering 30 or more stories. Shopping areas, where stores and whole streets recreate the character and adventure of places round the world. Theaters for dramatic and musical productions. Restaurants, and a variety of nightlife attractions. And a wide range of office buildings, some containing services required by Epcot's residents, but most of them designed especially to suit the local and regional needs of major corporations. But most important, this entire 50 acres of city streets and buildings will be completely enclosed. In this climate-controlled environment, shoppers and theater goers and people just out for a stroll will enjoy ideal weather conditions, protected day and night from rain, heat and cold, and humidity. Here, the pedestrian will be king, free to walk and browse without fear of motorized vehicles. Only electric-powered vehicles will travel above the streets of Epcot's central city. This towering hotel is the visual center of Epcot, the shining jewel at the center of the city. It will offer tourists and vacationers not only the most modern guest rooms and convention facilities, but also a 7-acre recreation deck located high above the pedestrian and shopping areas of the city. But hidden from view, directly beneath the hotel, is another kind of vital center, Epcot's transportation lobby. Although out of sight to hotel guests, this transportation terminal will play a key role in the city of tomorrow's ability to meet the needs of both visitor and resident. Two separate but interconnecting transit systems will move people into and out of Epcot in speed, safety, and comfort through this central terminal. Both are electrically powered. The high-speed monorail for rapid transit over longer distances, and a concept new to the American city for shorter travel distances, the Wedway People Mover. Automobiles and trucks will not be barred from Epcot. In fact, a vast armada of vehicles will continuously flow through the heart of the community, traveling below the pedestrian level on roadways reserved for specific types of vehicles. Let's look at another view of Epcot's transportation hub and see how traffic flows through the heart of the city on 3 separate levels. At the bottom of the stack is the truck route, reserved for supply vehicles. Trucks will have easy access to all loading docks and service elevators for the delivery of commercial goods. The middle level is the automobile thruway, exclusively for cars. Adjacent to the roadway are parking areas for the convenience of hotel guests. For the motorist just driving through, no stoplight will ever slow the constant flow of traffic through the center of Epcot. But automobiles and freeways will not be Epcot's major way of entering and leaving the city. The transportation heartbeat of Epcot will be the 2 electric-powered systems, monorail and Wedway, that radiate to and from the transportation lobby. And the key system in this coordinated network will be the Wedway People Mover. The first People Mover installation is already in daily operation at Disneyland. On peak days, it carries nearly 40,000 passengers. The cars you see here are approximately 5/8 scale, considerably smaller than full-size passenger cars would be for city use. Epcot's People Mover is a silent, all-electric system that never stops running. These cars continue to move even while passengers are disembarking or stepping aboard. Power is supplied from a series of motors embedded in the track, completely independent of the cars. No single car can ever break down and cause a rush hour traffic jam in Epcot. Because the cars run continuously, there will be no waiting in stations for a Wedway People Mover. The next car is always ready. Now let's go back to the transportation lobby and see how the Wedway will travel along one radial between the center of Epcot and a typical residential area. Leaving the transportation lobby, the Wedway trains travel above the downtown streets. Within minutes, the Wedway passes through the first station. Many people who work in the offices and stores of Epcot City Center board the Wedway here for their trip home. Some people leave the Wedway here, too. They live in Epcot's high-density apartments surrounding the Metropolitan Center. Most passengers who ride the Wedway live beyond the apartments and stay aboard the People Mover as it crosses Epcot's sheltering greenbelt. Epcot's greenbelt is more than just a broad expanse of beautiful lawns and walks and trees. Here, too, are the community's varied recreational facilities. Its playgrounds for children, its churches, and its schools. Beyond the greenbelt are Epcot's neighborhood areas of single-family homes. This is one radial neighborhood. Here and throughout the community, residents returning from work or shopping will disembark from the Wedway at stations located conveniently just a few steps from where they live. The homes are located in a wide green area that provides light recreation activities for adults and play areas for children. Circulating through this area are footpaths reserved for pedestrians, electric carts, and bicycles. Children going to and from schools and playgrounds will use these paths, always completely safe and separated from the automobile. The resident leaving home in his automobile will drive down a street reserved for motor vehicles. He then enters a one-way road that circles the city center. This road carries the motorist onto the main thruway connecting Epcot with other points in Disney World and with Florida's nearby network of major highways. But most Epcot residents will drive their automobiles only on weekend pleasure trips. From all over the community, residents going to their jobs converge by Wedway on the center city. Many work downtown in offices, stores, and shops. But most employees go beyond the city core to their jobs. From the transportation lobby, monorail trains carry employees either to the theme park or to Epcot's 1,000-acre industrial park. At this central station in the industrial complex, passengers disembark from the monorail and again board Wedway cars that radiate to each facility. This industrial complex will provide employment for many people who live in Epcot. But it will mean much more, not only for this community, but also for American industry. Here, the Disney staff will work with individual companies to create a showcase of industry at work. In attractive park-like settings, the 6 million people who visit Disney World each year will look behind the scenes at experimental prototype plants, research and development laboratories, and computer centers for major corporations. So this is Epcot, the heart of Disney World. In other parts of the country, a community the size of this prototype could become part of an entire city complex composed of many such communities, planned and built a few miles apart. In Disney World, about 20,000 people will actually live in Epcot. Their homes will be built in ways that permit ease of change so that new products may continuously be demonstrated. Their schools will welcome new ideas so that everyone who grows up in Epcot will have skills in pace with today's world. Epcot will be a working community with employment for all. And everyone who lives here will have a responsibility to help keep this community an exciting, living blueprint of the future. And now here again is Walt Disney.
That's the starting point for our experimental prototype community of tomorrow. And now, where do we go from these preliminary plans and sketches? Well, a project like this is so vast in scope that no one company alone can make it a reality. But if we can bring together the technical know-how of American industry and the creative imagination of the Disney organization, I'm confident we can create right here in Disney World a showcase to the world of the American free enterprise system. I believe we can build a community that more people will talk about and come to look at than any other area in the world. And with your cooperation, I'm sure this experimental prototype community of tomorrow can influence the future of city living for generations to come. It's an exciting challenge, a once-in-a-lifetime opportunity for everyone who participates. Speaking for myself and the entire Disney organization, we're ready to go right now.
Hello, I'm Leonard Maltin, and I have seen the future. It's inside this man's head. This is Ray Bradbury, the preeminent novelist, poet, thinker, futurist, and science fiction eminence. And it's a great pleasure to talk to you about a subject we both care about, Walt Disney.
Thank you. Thank you.
Thanks for talking to us, Ray.
It's a pleasure. Great to be here.
When did you meet Walt Disney?
It was a wonderful thing. I was Christmas shopping one day about 40-odd years ago. I was in a department store, and I saw a man coming across the store with a huge load of presents in his hands and his head tucked over the top. And I looked at his face. I said, my God, that's Walt Disney, my hero. I admired him since I was 8 years old. So I ran over to him and I said, Mr. Disney? He said, yes. He said, my name is Ray Bradbury. He says, I know your books. I said, oh, thank God. He says, why thank God? I said, because someday in the near future, I want to take you to lunch. And then he said, tomorrow? How about that? When's the last time someone said tomorrow to you? So the next day, I was in his office, had a card table, soup and sandwiches, and we babbled like a couple of kids.
What surprised you most about him as you got to know him a little bit?
What surprised me was how ordinary he was. In other words, there's nothing flamboyant there. It was like having lunch with my papa. But the great thing was that he knew that I listened, and he knew that I cared, and he would go out of his way then to entertain me. I went for lunch one day over the years, and on the way in, his secretary said, you have 1 hour at 1 o'clock out. He's got a busy schedule. I said, okay. So we sat at lunch and we babbled like always about everything. And at 1 o'clock, I jumped up. I said, thanks, Walt. I got to go. He said, wait a minute, I got something to show you. So he took me out on the lot. He showed me the new hippopotamus. They're working on a new Lincoln robot. He had to show me that. And the people mover. We came back to the office at 3 o'clock, 2 hours late. And the secretary looked daggers at me. And I said, no, him, you know. So that's an example. And enthusiasm was Walt Disney's middle name.
Absolutely. You could tell that from afar, and I'm glad that it translated to your meetings with him as well. Is the story apocryphal or true that you asked him about running for mayor?
We've had some bad mayors in L.A. and with rapid transit and all the problems. And one day at lunch I said, Walt, I really think you should run for mayor. He said, Ray, why should I run for mayor when I'm already king? Which I think is very good, very good.
Very good indeed. One aspect of Walt's personality and mindset and worldview was that he really was a forward-thinking man. And in many ways, I think he was a futurist. Would you agree with that assessment?
He was ahead of everyone in the whole world, as far as I'm concerned. The things he did as a cartoonist, an animator during the 20s and 30s, putting his reputation, his name, his money on the line. People told him that he couldn't make sound cartoons. He made them. They said, you can't make Snow White, it won't work. He put all of his money in that, got loans on the studio, put that out, very successful. Fantasia took a huge chance. It was years ahead of its time. It still is, still is. He gambled on that and for a little while lost because the film didn't make that much money. But then about 6 years later, it started going out in the world and people realized what he had done. So with Disneyland, with his work at the World's Fair in New York in 1964-65, proved that he was ahead of everyone, always.
And he led his colleagues, of course, and his staff in the same direction. And they often didn't know where he was leading them, but they caught on fast. And he seemed to be a great orchestrator of talent that way.
He had the sense, I think he was in a toy shop in London, and he saw one of these animators, future animators, buying a toy train. And as a result of seeing him buy a toy train, and Walt had a number of them at home, this fellow became an employee. So that's the way he chose. All of the people that Disney employed were gentle people, and he had the knack for picking them.
I want to ask you about some of the specific projects that he worked on, but before I want to sort of set the stage a little. For people who are too young to have experienced it and need to know a little about this, why did science fiction flourish as it did in the decade of the 1950s?
Science fiction started to come alive as a result of the impact of the various technologies. Radio during the 20s and 30s, then the invention of television started in 1929 but came to birth in 1945-46. So that by 1950, you had all this amassing of technologies and people's interest in what cars were doing to us, telephones were doing to us, and what TV was doing to us, plus the atom bomb. So with the impact of all these technologies, it was only natural that eventually someone would say, why don't we begin to do films about this? Why don't we do books about this? And I was lucky to be born at just the right time and came to fruition when I was 30 in 1950, and I've benefited from this.
What year was The Martian Chronicles first published?
1950.
1950. And then how many years later was Fahrenheit 451?
3 years later.
You were right in the midst of all of this.
Yes, indeed.
Well, in 1954, when Walt Disney put his Disneyland TV show on the air, and while he was building Disneyland, the park, one key element was Tomorrowland. And I wonder if there would have been a Tomorrowland as effective at any other time as it was right at that moment in the 50s. He too was in the midst of that decade of thought and imagination and worry and fear and projections about the future.
He reminds me of that fabulous story of the man who jumped on his horse and rode off in all directions. In other words, there were 4 parts to Walt, as there were 4 parts to Disneyland. So he knew enough to pay attention to the past, he knew enough to pay attention to the present, and then he had the foresight to talk about the future. I was very protective of him and Disneyland. I went there the first time with Charles Laughton, the great English actor, and he took me around Disneyland, and he became Captain Bligh when we got on the Jungle Boat, and he keel-hauled people all the way around the ride and plowed through the crowds and took me on the Peter Pan ride over Big Ben at midnight. So when intellectual critics from New York criticized Disneyland, I wrote a letter to the nation saying, if it's good enough for Charles Laughton, it's good enough for me. Let me give you another story. I came back from Paris one time about 10 years ago, went to Disneyland, and I looked on the side of Sleeping Beauty's castle, and I called John Hench over at Imagineering. I said, I just noticed something about Sleeping Beauty's castle. There's a spire there that I saw last on top of Notre Dame and the Palais de Justice in Paris. I said, how long has that been there on Sleeping Beauty's castle? He said, 20 years. I said, who put it there? He said, Walt did. I said, why? Because he loved it. I said, that's why I love Walt Disney. It cost $100,000 to build a spire you didn't need. The secret of Disney is doing things you don't need and doing them well, and then you realize you needed them all along.
Everything contributes. Everything adds to the whole. I've been watching the Disneyland TV shows, the Tomorrowland shows that were done in the first season when Ward Kimball did a series of shows about space travel. And they called on people like Willy Ley and Werner von Braun and Heinz Haber to project into the future, the near future, as it turned out. But what occurred to me in all of this was that so many people who look into the future see only bleakness, see only the worst that humanity will suffer from the changes and the upheavals. Walt was an optimistic futurist, and that's rare. Could you comment on that?
If there's any secret at all, it's because Walt, like myself, is not an optimist, but an optimal behaviorist, which means that every day of your life, if you behave well, you begin to feel well, huh? So that's not false, that's real. You get your work done every day, And at the end of a week, a month, a year, you turn around and say, hey, look what I did. So you feel good. That's real optimism, optimal behavior. So that's, I think, the way he behaved. And he could look back at the end of each year and see his behavior, and it made him want to go on. A lot of people are pessimists because they've never done anything. If you go to bed every night having not done anything, you're going to wake up unhappy, aren't you? So the answer to that is do something every day. Be busy, for God's sake. Be busy.
Well, he certainly subscribed to that.
Yep.
When he put those shows on the air about space travel, and also a famous show called Our Friend the Atom, which Heinz Haber had a lot to do with, he was really doing two things. He was educating America, but he was also kind of propagandizing or proselytizing, I don't know which would be the right word, for America's involvement in a space program. And that show was so popular, and he carried so much clout that he earned with the American public.
Yes.
I think the impact must have been tremendous.
Oh, absolutely. I remember at the time seeing those shows, and they were completely alone. There was no one else in the field, no one else that cared. And finally, Kennedy came along a few years later, and we promised ourselves to the moon.
I wonder if those shows had never been broadcast, if public sentiment would have been as enthusiastic, would have gone along with the idea quite as easily.
Indeed, it did help very much, yes.
In fact, Disney used the term science factual because all of those shows were based on fact and based on the experience of these renowned scientists. How would you delineate the difference between science fiction and science factualism, if there's such a word?
They're begging the question. The history of mankind is all science fiction. It starts on the walls of the caves in the south of France. You go and look at the walls of the cave, and they're covered with science fiction pictographs, pictures of men solving problems. How do you kill a wild boar? How do you kill an elephant? How do you kill a wildcat? So you have to dream killing in order to kill. You have to invent bows and arrows. You have to invent spears, because a spear is an extension of your hand. A bow and arrow, all these things are extensions of the mind. So you dream a thing first. That's science fiction, primitive science fiction. Then you build it, and it's science fact. But the science fact comes after. You can't claim a thing as science fact. You have to do the dreaming first.
When did you first have occasion to work for and with the Disney Company?
I wrote an essay about Herman Melville and Jules Verne as being great representatives of the American will, the American blasphemy. Jules Verne was our French uncle, but part of the American blasphemy of opposing nature on the proper grounds. Ahab went too far, saying he would strike the sun if it insulted him, and Nemo came along and said, don't strike the sun, plug into it with the scientific method and light the seas of the world. When I wrote this essay, people in charge of the United States Pavilion at the New York World's Fair read it and came to my house here and said, we've come to give you a $50 million building. I said, come in, come in. And I said, what's this all about? They said, we're building the United States Pavilion, and we think you can do a history of the United States, starting with Columbus and ending with space travel. So because of that essay, I took over. The Disney people saw, long way around to the point here, the Disney people saw what I'd seen, what I'd done, and they came to me and said, we have a $50 million building too. Will you help us stuff it with metaphors? So I worked with John Hench and helped create Spaceship Earth down at Epcot.
Now, Epcot is another great, of course, manifestation of Walt's interest in the future and what the future could mean to all of us, to the average person, in changing what we see as our everyday life.
When I was a kid, I went to see the Chicago World's Fair, the Century of Progress. I was madly in love with it. I became an architect in my mind. I didn't want to go home at night. It was so beautiful. My parents had to drag me out. Then I discovered 2 years later that the damn fools are going to tear it down. And I thought, how stupid to tear down a dream when we need it, huh? And all the world's fairs, except in the case of the French, they were smart and kept up a lot of their buildings from 100 years ago, the Eiffel Tower and the Palais, the Grand Palais, and what have you. So I always thought when I was a child that someone should build a permanent World's Fair and improve our minds and educate us to dreams constantly, day after day, for a lifetime. And that's what Disney did. They built Epcot. It's a permanent World's Fair. It sheds its skin on occasion. They put in new exhibits. So they refresh the whole process. And if that doesn't represent Walt Disney, nothing does.
Now, he had originally dreamed of building a community, a city of the future. That was his first design for Epcot. I always thought that was such a fascinating idea. Do you think it could have worked?
It needed the dream at the center. You can't just have a community. You have to have some central thing that holds the whole thing together. And so I think Epcot holds the community together, and they're building things around the edge now. Eventually, all of Walt's dream will be complete.
Does it make sense to you, looking back at Walt's career, that this man who started with animated drawings should become an urban designer?
That's a great thing. I'm glad you asked that, because he built Disneyland, because it was full of things we didn't need but really needed. We don't need a lot of trees, you plant them. We don't need a lot of benches, you put them down. You don't need a lot of flowers, you plant them. That's French. That's out of Paris, the environment of Paris that Walt learned and grew up with. So he built Disneyland as an example, a way of living, not just an entertainment center. You can go there and sit on a bench and people watch, because it's a happy experience. Why? The flowers, the trees, the fountains, all over and above all the other elements. So he was teaching us urban planning, though he didn't intend to do it. I took some architects out to Disneyland, and I took them to meet John Hench 35 years ago. And I worked on a mall myself, but was influenced by what I saw at Disneyland. This goes way back to a time when he was still alive, huh? But I took all my architectural friends there, and I introduced them. I said, you can learn from Disney and from Disneyland. And they went out then, people like John Jardy, and built malls all over the world. His influence has changed the entire world, not just part of America.
The mundane but nice idea of an amusement park, and did something different with it. He built an environment, and no one had done that before, had they?
That's right, yes.
What I love about walking into Disneyland still to this day is that you're in a place. You're in a place that's not like any other place on Earth.
Well, we all want to build a time machine, don't we? We all envy, we like certain stories, like H.G. Wells' Time Machine. So when you enter Disneyland, you're entering a time machine, and you can take various avenues. But the main drag is my grandmother's time. Just a few years before I was born, I could walk down that street in Waukegan, and there it was. But perfect, perfect. And then you take a turn over here, and you're in wilderness country. And then you take another turn, you're in jungle country, where you wanted to be when you were 10 with Tarzan. And then you take another turn, and you're in the future. So the whole thing is one fabulous time machine with a series of doors you can open and go into the past or the future.
And yet, it also is very indicative and reflective of that one man, Walt Disney. because that Main Street, for instance, is his idealized Main Street, having grown up in the Midwest. And somebody building a similar park today might not have those feelings at all for that kind of a centerpiece. But it meant an awful lot to Walt, didn't it?
Well, he was an unusual man. Walt was a dramatist of the human condition. I've been writing a short story recently about a time machine, an ordinary time machine. You get it and you go back in time in order to get a glass of lemonade from your daughter out on the sidewalk on a hot summer when she was 10. And that's this thing here that Walt can do for you. You want to go back and have a drink of lemonade on a day that's been lost for a long time, he'll do it for you.
Do you have a favorite ride or attraction at Disneyland?
Oh, I have a number. I love the Pirates of the Caribbean. I was there when they were digging the hole and walked through before they put the water in. And the haunted house, too. I walked through and tried to give them some ideas. I felt privileged to be there and walk around with John Hench and with Walt on occasion. But it's terrific, terrific.
What do you think the world lost when Walt died? And he died so young.
They didn't lose anything. His personality, his memory is so strong that the world goes on changing. We've got the Grove Mall that opened here at 3rd and Fairfax recently. That's pure Disney. It's built by all the people that he influenced when he was alive. People are always saying to me, do you believe in immortality? I said, yes, I do. I said, I have 4 daughters and 8 grandchildren in my books. I'm immortal. Maybe for only 40 years, but Walt is immortal for the next 100 years.
What's the quality you admired most in Walt Disney?
The quality I admired most was if he knew you cared, if he knew you were as enthused as he was, then he spent time with you. He must have recognized that in me that day when he saw me shopping at Christmas, a kindred spirit. So it's that ability to know when someone's really listening. You don't want to wander around a shop and pretend to care about what you're seeing, because the Disney studio is a Renaissance shop. The Renaissance is not dead, it's still alive. All these crafts and arts are still alive because of that enthusiasm.
Ray, thanks so much for sharing your thoughts and your memories and your ideas and your great spirit with us.
Thank you. It's been a pleasure.
Hello, I'm Leonard Maltin, and I'm very happy to be here today with Marty Sklar, who is the Vice Chairman and Principal Creative Executive of Walt Disney Imagineering, and a man who's spent a lot of time not only with Walt Disney, but thinking about the same things Walt thought about. When did you start to work for Walt Disney?
About a month before Disneyland opened, in June of 1955.
The Disneyland Park and the Disneyland TV show came into people's consciousness about the same time, and they both featured one significant element, and that was Tomorrowland. And that's what we want to talk to you about. Was Walt as futurist and visionary in a literal as well as figurative sense? Can you give us an idea of what the thinking was at that time about Tomorrowland and what it represented and what then was expressed on the TV shows?
Well, I think one thing you had to know about Walt Disney was he would frequently go around to the great laboratories of American industry at that time. And of course, for Walt Disney, they always trotted out the most amazing things that we're working on. And that, I think, spurred Walt's interest in Tomorrowlands and future things.
Would you think of him as a futurist?
Oh, absolutely. And he was always going beyond what he had done the last time and using technology to tell his stories.
That's a good one. How would you like to have one of these little dinosaurs for a pet? Actually, they're tame as a kitten, quite friendly, and they won't bite the hand that feeds them.
You know, we used to say about Imagineering, this was the way Walt loved to describe it, that it's a blending of creative imagination with technical know-how. And the technical know-how, he was always reaching for something new, a new way to tell stories.
In the most famous, arguably most famous World's Fair of the 20th century, the 1939 New York World's Fair, the theme was the world of tomorrow. And most World's Fairs look to the future in some way, but that was a particularly significant one. How would you differentiate what Walt did at Disneyland from what people saw in that 1939 fair?
Well, two things come to mind immediately. One was, in retrospect, the Second World War came along, and all of a sudden, so many of the things that were predicted at that fair were put on hold. So for many years, it appeared that that fair had set out things that were almost in the far future rather than the near future. The other thing that I would distinguish is that Walt really wanted people to participate. And so all the Tomorrowlands aimed, Autopia cars, riding a monorail, all of those things that he really wanted people to be able to experience. You know, it's the old story about seeing an apple and taking a bite of the apple, and he always wanted people to be able to take that bite.
America in the 50s was healing from World War II and the Korean War, and it was the era of the baby boom, a time of prosperity. And from this sprang Disneyland and a lot of Disneyland TV shows. The space program was the next step beyond that, but I wonder about Tomorrowland itself. When you opened the park, everything in it was just so incredible, so unlike anything anyone had seen at Coney Island or, you know, Pacific Ocean Park or any of the older playgrounds or amusement parks.
Actually, Tomorrowland and Disneyland the first year was not very good. It had things like the bathroom of the future, if you could picture that.
I'm sorry, I missed that.
Yes. And it had a satellite view of America where you got on a platform and went from day to night and saw what the country looked like from a satellite view, which of course there was no satellite at that time, so it was all depicted by the Disney artists. Walt wanted all of that out, you know, quickly. Disneyland opened in 1955. By 1959, he'd replaced half of what was in Tomorrowland. We were working on a whole new Tomorrowland when Walt passed away, and it opened just after he died, and that was when the People Mover came in, and then he brought the Carousel Progress from the New York World's Fair, and the Carousel, it turned out to be an excellent way of depicting the future, because we didn't have to change the 1890s to that. We didn't have to change the 1920s and the 1940s. All we had to do was deal with the last act. And so we always kept changing the current and a little step into the future.
Walt, particularly in that Carousel of Progress, expressed what was said in that Sherman Brothers song. It's a great, big, beautiful tomorrow. He's the only futurist I know who had a smile on his face about the future.
Well, first of all, Walt Disney was the eternal optimist, and he really believed that things could be better. And Bob and Dick Sherman wrote that song as a personal ode to Walt. And they really meant it, a great, big, beautiful tomorrow shining at the end of every day. Well, that was Walt's anthem. and they recognized that.
There's a great, big, beautiful tomorrow, just a dream away.
Well, a beautiful tomorrow, just a dream away. That says we're going places. There's progress ahead.
One of the high points of the early TV shows was the series on space exploration. And one wouldn't have automatically associated Walt with space exploration and a serious examination of where America was heading. Did you ever get a sense of why he was so enamored of that?
I think it was this whole idea of showing predictions of the future. And he brought in a lot of the people that were involved in the American space program. And they became his consultants, if you will, and his advisors as to the kinds of predictions he should make out of those TV shows. We do know that they were seen by President Eisenhower and that it was a stimulus to him for pushing the American space program.
Walt had an amazing capability, it was always said, of not only discovering and nurturing talent, but channeling talent into unexpected areas. I'm going to ask you later on about your own experiences, but one wouldn't have thought immediately of Ward Kimball as the man to supervise those shows, but you wound up working with Ward quite a bit in later years. What do you think it was about Ward that made him the right guy, which he turned out to be?
Well, it probably was two things. The first, Walt might not have had a specific assignment for Ward at that time. But the other thing is, Ward was, as Walt said, the real genius in the organization. And I think he knew that Ward would get fascinated by the whole idea of being able to travel in space. You know, he was always stepping out and trying something different. And, you know, I think that's probably a lot of what Walt admired in him, because that was Walt, too. Walt always said to us, I'm not interested in what you did yesterday because I'm not going to be there. I know I can do that. It's the next thing that I'm interested in.
Do you remember your feelings as America did enter the space race and as we started chalking up those incredible milestones? What did it feel like for you, having worked, you know, in a kind of an entertainment or informational way on some of the same subject matter?
Well, I think the most exciting time was when we first landed on the moon. And I was out in Tomorrowland at Disneyland with the flight to the moon, and there were thousands of people who wanted to be there at that location to see whether what we had predicted was actually the way it turned out. And they weren't disappointed.
Oh, that's the highest compliment I would think you could have, that your futurism, if there is such a word, turned out to be a pretty good reality when that came to pass.
Yeah, I remember John Hint saying, well, I wonder if people are going to be disappointed that they didn't jump quite as high as our people did.
Now, you also worked with Walt on the '64 New York World's Fair, which was one of the high points of his later career. Tell us what kind of things he wanted to achieve there. Now, a lot of those were commissioned projects, but I'm sure the creative end of it came from the Disney people.
I think he had two primary objectives. The first was to continue to build Disneyland, and so all the things that he developed for that 64, 65 New York World's Fair, in one way or another came back from the fair to Disneyland. That was one objective. The other, it was a stepping stone to the Walt Disney World project, because at that time it was very hard for Disney to get its pictures played on Manhattan Island. And there weren't a lot of theaters that played the Walt Disney type of picture. And so there was a real interest on his part in communicating to that, quote, sophisticated New York audience about the kind of entertainment that Disneyland had been putting on for 10 years by that time.
One of Walt's great dreams was building a city, a community of the future, and that's what Epcot originally was intended to be. Can you talk a little about that and his original plans or dreams for that?
When he saw a problem, he would identify with it and try to find a way to solve it. And I think that's where the whole idea of Epcot came in. And what's amazing to me, and I didn't even know all of this at the time, but Walt had so many different people working on aspects of a city of the future. He was really into it.
I remember reading with great fascination about his ideas for this model city. And some of the things he thought about have been adopted, like putting power lines underground. But he had more advanced even ideas than that in terms of traffic flow and controlling that so there wouldn't be congestion and there wouldn't be traffic jams that inevitably occur in any city of any size. What do you think his model or utopian community would have been like?
It's interesting you use that word because when I was first asked to do some work on the Epcot project, I came back to my boss, Dick Irvine, who ran design here at Imaginary, the next morning, and I said, I think the name is wrong. And he said, what do you mean? And I said, well, I think it should be called Waltopia. Now, unfortunately, I didn't win, but I don't know if it ever got to Walt, but it really was. It was Walt's vision of a utopian place to live.
I believe we can build a community here that more people will talk about and come to look at than any other area in the world. I'm sure this experimental prototype community of tomorrow can influence the future of city living for generations to come. It's an exciting challenge, a once-in-a-lifetime opportunity for everyone who participates.
What was the purpose of that Epcot film?
Walt really wanted to communicate what he was planning to do. There were two publics, if you will. The first was the legislature in the state of Florida, because without getting certain powers, if you will, directly for the Walt Disney Company, he couldn't achieve a lot of things that he really wanted to do. That was one. And the second was to the public. He wanted to say to the public certain things. And actually the third was American industry, because he knew he couldn't do this by himself. He had to have the kind of the World's Fair setup. And actually on the Epcot film, he had me write two endings. One was directed toward the state of Florida, public and legislature, and the other was directed to American industry. And he was pushing me because that was the last time Walt was ever on film, was the Epcot film, and those two endings were the last things we did. Oh, Ever the Salesman.
And it was considered a success, and obviously it did achieve its goal, didn't it?
Oh, absolutely. We used the film about 4 or 5 months after Walt died for the first time, and it went to the legislature, and it was used on public television in Florida, and really raised the level of understanding of what Walt Disney World was going to be.
Tell us a little about how Epcot was eventually designed and what were the priorities. Walt had passed on by now, and Epcot changed from being a model community to kind of an exhibition hall about the future.
Well, the first thing that happened after Walt died was there was even a question of whether the company was going to go ahead with the Walt Disney World project. And Roy O. Disney made a fantastic commitment to making the Walt Disney World property and project a reality for his brother.
As Walt said, this city of tomorrow will always be in a state of becoming, and it will never cease to be a blueprint of the future.
And in fact, Roy had planned to retire and then came out of retirement basically to lead that effort, and he put so much into it that 3 months after we opened Walt Disney World in October of 1971, he passed away. And so we really had to establish the Walt Disney World Resort as a place where people went for their vacations. It wasn't until around 1975, almost 10 years after Walt died, that we were asked to look at the Epcot idea again. Then Bard Walker...
He was then the chairman of the Walt Disney Company, wasn't he?
That's correct. Said, we have to figure out how we're going to proceed with Walt's idea for Epcot. So we started having a series of meetings where we brought together people from government, from industry, and from the private sector and academia. And we had a conference on energy, we had a conference on transportation, we had a conference on food. One of my favorite experiences was when we opened the Land Pavilion at Epcot. And we had been working with a man by the name of Carl Hodges, who was the director of the Environmental Research Lab at the University of Arizona. And they helped us, they designed the food growing systems. And we were outside the pavilion, all of a sudden he stopped dead in his tracks. And I said, Carl, what's the matter? And he said, I just realized that in the next 3 or 4 hours, more people will see my work than in the 30 years I've been doing this. Now that's impact, I think, and communication of some wonderful work that only some people in the field had known. Now the public was getting all this.
You took these things out of the lab and put them into public view, and very prominent public view.
Nobody listens to the government when they proclaim things in most of these areas. Nobody trusts industry because they have an axe to grind. But everybody trusts Mickey Mouse. So everybody fed back to us that we had a role to play in communicating many of these subjects.
Has Epcot changed as much as Tomorrowland has had to change to keep up with this constant chasing the future?
It's changed in some degrees, importantly. In other ways, it hasn't changed enough. We're doing a pavilion right now called Mission Space, which will open late this year. You know, that future is a moving target, and it moves faster and faster, as a matter of fact. So we have a big challenge in keeping up with that.
That's a wonderful circle that's come around, though, that from the beginnings of Walt and Disneyland's involvement with space, and even prodding America toward interest in space exploration, you're now doing it again at Walt Disney World.
And that's a good point, Leonard. It is full circle, and I think Walt would be very proud of this one.
Can you summarize in any way, you've had so many years of experience in different arenas, even under the umbrella of things you've worked on for the Walt Disney Company. Can you summarize the kind of lessons you took away from Walt, particularly as regards his constant looking toward the future?
Curiosity, a big one. Always wanting to learn more about whatever subject you were dealing with and really know it. Courage. You know, when you've decided that this is something you're going to do it right, absolutely right. Quality. Walt was so focused on quality and giving the public more than they would expect. And the optimism piece. I mean, he really believed in that. But I think, and storytelling, of course. I mean, almost everything that we have done successfully is a great story to begin with. How it's interpreted in a three-dimensional environment is, there's a lot of different options, and some work better than others. But if it's got a good story at the heart of it, I mean, how are you ever going to top the Pirates of the Caribbean, for example? That's a quintessential idea and show. And so I think those are the kinds of things that we all learned from Walt Disney.
How did you come to be Walt's communicator? That's really what you were at one point, isn't it?
I don't know. I just was kind of in the right place at the right time, and had the opportunity to write a few things for Walt that he really liked. And so he would, like everybody else, he would send out a new challenge, and if you were up to it, you went to the next rung on the ladder.
Well, that means you must have been able to, in a sense, get inside his head. No one could have fully understood the genius that was Walt, but you must have understood to a pretty great degree how he thought and how his thoughts came together.
Well, I've expressed it this way. You know, I never had to think like my father as much as I loved him, but I had to try to think like Walt Disney because I had to find words that he would be comfortable with saying. And, for example, one of my favorites was the word things. Now you say, well, that's such a nothing word. But Walt would say, now the pirates are going to sack and burn the town, and then we're going to do some really exciting things. And when he said that word, he just let it hang.
You see, our whole 40-some-odd years here has been in the world of making things move, inanimate things move. From a drawing through all kinds of any little props and things.
You know, the first time I heard him do that, I said, I'm going to write that word in almost everything I do with him because it painted pictures beyond what you could imagine. And when I could find little things like that and bring them out and know that when he said them, that it would have a whole new meaning, that was a great challenge and a great satisfaction.
How would you describe what you do, Marty?
Oh gosh, that's a hard one. I think the wonderful thing about my job is that there's so much talent here, and everyone has new ideas and want, obviously, to sell their ideas to the management of the company. So what's difficult for me to think about doing something else or retiring is the fact that I come into work every day and there's new drawings, there's new ideas, there's people with passion about what they do. And I think, if anything, what someone in my position does is enable those ideas to come forward and to have a chance at becoming reality.
What else gives you satisfaction at this stage of your career?
Well, at Imagineering, first of all, it's the reputation of Imagineering, and wonderful thing is receiving letters constantly from young people who want to become Imagineers. That says a lot. You know, Walt started bringing some of the great talents from the studio to Imagineering. He would bring Mark Davis and Claude Coates, a great background artist from animation, and John Hinch, and Lane Gibson, and his sculpting talent. He didn't know he was a sculptor, but Walt told him he was a sculptor. And all of these people trained us all in goals they set and the quality of the product that they developed and their storytelling talent and the attention to detail. And all of that has gone into this great mix that Imagineers now draw on. And I actually think there's more talent here today than there's ever been, which is a great tribute to Walt and those who went before us, and a great challenge for anybody new that comes in here.
Just to sum this up, Marty, you were recently profiled in the Los Angeles Times, where they described you as kind of a living link to Walt Disney for so many people who work here in the company, that they look to you because they know you were part of his inner circle. How does that make you feel?
Old.
No, but you have the magic. See, you did get something from working here. You have a youthfulness of spirit.
Well, it's a challenge. You know, next month, Leonard, I'll be 69, and you know, you think about what you're going to do with the rest of your life. And I have people come to me almost every day and say, "Marty, you can't leave. We need you here. You keep the thread." And so that's hard because, you know, do you live outside your own body, or do you say, you know, there's other things that I want to do? And as I said earlier, the good news is that when you come in every day and there's so much energy and passion for what we do here, that makes it a little easier to stay around and grant the wishes that so many people express to me.